Hello everyone. Hello my dear friends. Welcome to free online classes of the subject physics by Professor R.D. Lambur. Dear students, I have decided to post my physics lectures on my YouTube channel. I will be posting a complete lecture series on all the topics of 11th standard as well as all the topics of 12th standard of the physics subject. So like, share and subscribe to my channel to stay updated and get assured success. Dear students, after this short introduction, let us begin with basic meaning of physics. So, what is physics? Let us try to find the meaning of physics in this. So, physics is branch of science, one of the branch of science. Science has many branches, but a branch of science which deals with the study of nature and various natural phenomena which are taking place in the nature, just like lightning in the sky, waterfall, or falling of the fruits from the tree, planetary motion. Number of natural phenomena are taking place in the nature. And study of such natural phenomena in detail is in one of the branch of science called as physics. So physics is nothing but knowledge about the nature. Therefore, in the physics, we study nature and various natural phenomena in detail and in depth. So, the physics is a very vast subject. Due to this reason, physics is divided into two branches: classical physics and modern physics. Physics before 1890 is the classical physics, and after 1890 is the modern physics. In classical physics, we study macroscopic objects, motion of macroscopic objects, just like study of car, study of person in motion, whose speeds are less than the speed of light. While in the modern physics, we study the motion of microscopic objects, which cannot be seen by naked eyes, just like electron, proton, nucleus. This classical physics has few more branches: mechanics, kinetic theory of gases, thermodynamics, sound, optics, electricity, and magnetism. Number of branches this classical physics has. At the same time, modern physics has few more branches. For example, quantum physics, nuclear physics, atomic physics, molecular physics, like that. So, we will try to find out meaning of the mechanics in the next slide. What is mechanics? Of course, it is a branch of classical physics. And this mechanics deals with the motion, deals with the forces acting on the objects. The objects may be at rest or objects may be in motion. So branch of classical physics dealing with the forces acting on particles. Either they are at rest or in motion. This is the mechanics. And this mechanics has two branches. First one is the statics, and second one is the kinetics. In statics, study of objects at rest. The forces acting on objects which are at rest, their study is in statics. While in kinetics, we study the forces acting on the moving objects. So in this way, mechanics has these two branches. After that, this kinetics has again two sub-branches. First one is the kinematics, and in the kinematics, we study motion of object without considering the causes. Means simply, we want to study only motion. We don't need the reason or the cause which has produced the motion. And when object is in motion, it covers distance, it has displacement, it has speed, it has velocity, it has acceleration. We will only study the motion without considering the causes for the motion. That is in the branch kinematics. And the second branch of kinetic is the dynamics. And in this branch, we study the motion of object along with its causes. This is the difference between kinematics and dynamics. When body is in moving, and if we try to find out the reasons, the causes for motion, then that study is in the branch dynamics. After that, we will try to understand the meaning of the terms motion, kinematics, dynamics. For that, let us see our next slide. What is motion, dear students? You have studied it in previous syllabus. This is nothing but change in position of object with time. When object changes its position with time, then that object is said to be in motion. Example, a rolling ball. You can get detailed idea from this picture. Object is nothing but a ball, and this ball is initially at position A when time here is 0, and it is changing its position from A to B in 1 second, you can say 1 minute, you can say. So ball is changing its position with time. Therefore, this ball is said to be in motion. And this time is mentioned here. This one is the time, 0 to 1. Means when ball is at position A, starting time 0. When it reaches to position B, it takes the time 1 minute, 1 second, whatever. So, in this case, ball is moving from point A to point B. We can also observe the change in time which is given in the right corner of this picture. Now we will try to study kinematics. As already we have cleared, in kinematics, which is sub-branch of kinetics, and kinetic is the branch of mechanics. So kinematics deals with the study of objects without considering the causes of motion. A branch which deals with study of motion without considering their causes is called as kinematics. And what is dynamics? Dynamics deals with study of motion with considering its causes. To understand difference between kinematics and dynamics, we will try to study in more detail. In this picture, this ball is held by this person. So, what happens after that? See, that person is now throwing the ball. So if you want to study throwing of ball, ball will move. It will cover distance. It will gain velocity. It will gain speed. It will gain acceleration. So throwing of ball set the ball in motion. And if you study only throwing of ball, then that will be in the branch kinematics. But here, can you see this? To throw the ball, hand is supplied the force. Means force is applied by this hand. So if you study throwing a ball and applied force, then that will be in the branch dynamics. So force applied by his hand is the cause for the above motion. So motion by considering the cause, dynamics. Motion without considering the cause is the kinematics. So when we say dynamics, we will study the motion, that means throwing ball, along with its causes, that means applied force. So this clears you the difference between kinematics and dynamics. After that, within few seconds, we will just revise, we will just clear which topics, which sections, which units are set to our new syllabus, 12th standard new syllabus. Our 12th standard new syllabus is divided into total 6 units. These are the 3 units shown here, and 3 units will be shown in the next slide. So 12th standard physics syllabus is divided into 6 units. First unit, rotational motion and mechanical properties of fluid. This unit has 2 chapters. Second, kinetic theory and thermodynamics. This unit has also 2 chapters. And third unit, oscillation and waves. This unit has 3 chapters. After that, fourth unit, electrostatics and current electricity. This unit has 2 chapters. Fifth one is the magnetism. This magnetism has 4 chapters. And the sixth one is the modern physics, which has 3 chapters. So in all, there are 6 main units and there are 16 chapters for your 12th syllabus. And if you find out the names of the units gives you the idea about the various branches of physics. So you can clearly find out that few of that chapters are from the classical physics and the remaining chapters are from the modern physics, isn't it? I will clear you. First to 13 chapters are from the classical physics. And after that, 14, 15, 16, last 3 chapters are from the modern physics. Okay. That is only to understand various branches, and from each branch you are studying one or more chapter. So dear students, let us start first chapter of the 12th standard syllabus, the name Rotational Dynamics. And now you will clearly got idea why we were clearing the meaning of kinematics and dynamics. Rotational dynamics This topic is divided into two subtopics. Circular motion is the one, and rotational motion is the second. And in circular motion, we will study about the horizontal circular motion and about the vertical circular motion. So clearly, rotational dynamics has first half part about the circular motion and last half part about the rotational motion. What are the contents of this topic? This rotational dynamic contains these subpoints. Horizontal circular motion is there, and in that horizontal circular motion you are going to study kinematics and dynamics, its application. Vertical circular motion is there. Here also you are studying applications. Moment of inertia is there, radius of gyration is there, theorem of parallel and perpendicular axis is also there, angular momentum, rolling motion. And before starting the topic rotational dynamic, we will try to find where is the base of this topic. Of course, we are studying the circular motion, which is a subtopic of rotational dynamics. And about the circular motion, you are studied in the 11th syllabus in the chapter 3, motion in a plane. That means from that motion in a plane, you must revise few points. Due to this, you will clear the basic of rotational dynamics. Which points you have studied in the 11th standard? Let us see. Of course, topic number 3, motion in a plane, and in that topic we have studied about circular motion, radius or position vector, angular displacement, angular velocity, uniform circular motion, period and frequency of revolution, centripetal acceleration, conical pendulum. All that points we have covered in the 11th syllabus, topic 3, motion in a plane. So you have to revise, you have to remember the meaning of all these concepts from the 11th syllabus. Due to this, there will be no difficulty to understand the first topic from the 12th syllabus, rotational dynamics. And as we have said that the first part of that rotational dynamic is the circular motion. And in circular motion, the first part of the lesson talks about the topics considering horizontal circular motion. And the second half of that lesson, we will discuss vertical circular motion. And this diagram clearly explaining this. This conical pendulum, whose bob is performing, whose bob is describing horizontal circle, performing horizontal circular motion. And this one, motion of body in a vertical circle. As we know, a rolling coaster or giant wheel, they are performing vertical circular motion. So, to start about the circular motion, we must be clear that in that circular motion, the first part talks about the horizontal circular motion and the second half will talk about the vertical circular motion. In the 11th standard, we have studied motion but along line. That is linear motion you have studied in the 11th standard. Here we will study circular motion, rotational motion, but by considering their causes. And any motion, by considering its causes, is nothing but dynamics. That's why the name is given to your topic, rotational dynamics. Do you recall? These are the questions which are set in your syllabus in the textbook. What it means? There are few concepts, there are few terms which are in your syllabus, that must be recalled because that terms are founding as a base for the understanding. Then which terms you have to recall? First one is the circular motion. You all know the meaning of circular motion is known to us. Motion of an object along the circumference of circle. Very easy. Number of circular motions are taking place in our everyday life. When we are driving along a turn, our vehicle is performing circular motion. Moon is performing circular motion around the earth. Earth is performing circular motion around the sun. Different planets are performing circular motion around the sun. Very easy. So, why we are studying circular motion? Why study circular motion? There must be some reason. So, circular motion is studied because we want to understand motion of planets, motion of electrons around the nucleus, motion of giant wheel, motion of space stations, motion of moon and satellites. To understand all that motions, we are studying about the circular motion. For circular motion, it is not necessary that the body should complete a full circle. Means if a body is moving along some part of circle, some arc of circle, then that motion can be considered as a circular motion. Circular motion is an essential part of our everyday life. As I have said, when our vehicle is taking a turn towards left or right, while the vehicle is moving along that turn, it is performing circular motion. So circular motion is an essential part of our everyday life. And in our everyday life, we come across several revolving and rotating objects. Number of objects are there which are revolving as well as rotating in our everyday life. If you take example of electric fan, that electric fan is performing a rotational motion. But if you consider motion of each and every particle of that fan, then that particles are performing revolving motion. So in this way, you can understand the difference between revolving and rotating. As we have started to study about the circular motion, these are the few pictures which will clear you what is the circular motion. In the first picture, the satellite is revolving around the earth, circular motion. In the second picture, there is a giant wheel, vertical circular motion. In the third picture, athletes. Before throwing this object, this athletes has to complete certain number of rotations. And then he will throw this object to gain maximum result. Fourth picture gives you planetary motion. And fifth one, bicycle riders are taking this turn. Here you are not getting a complete circle, but some part, arc of circle. So if a particle is moving along the arc of circle, then its motion can be considered as circular motion. So in this way, we have completed the first point of recall. What is it? Circular motion. We will see about the second point. What is it? This point we want to recall from the previous syllabus. Do you know about the center of mass? It is also called as CM. Each and every body has its own center of mass. What is it? It is an imaginary point which is inside the body, at which whole mass of the body can be supposed to be concentrated. So center of mass is an imaginary point at which whole mass of that body is supposed to be concentrated. To understand this concept in detail, let us see this picture. In this picture, this person, this scientist, is along with baseball bat. And this scientist has supported this bat at this point. Means he has applied force at this point. And due to that, this baseball bat is balanced. Very easy. What it means? The force applied, the point at which the force is applied, this point is nothing but center of mass of that baseball bat. And if the point of application of force shifts towards left or right, the baseball bat loses its balance and will fall down. So baseball bat balances when the force is applied, when it is supported by applying force at its center of mass. I will give one more example to understand this concept. See this diagram, see this picture. In this picture, person is same, but it has three different positions. In the first position, the person is standing. In the second position, he is running. And in the third position, he is giving a kick. But can you differentiate the position of center of mass? Is it changing or remaining the same location? You can easily find out. When it is standing, the center of mass is at this point. When it is running, the position of center of mass is slightly shifted. When it is giving a kick, center of mass has changed its location. What is the meaning? The center of mass gets shifted as per our position. Means if we change the position of our body, then center of mass of our body will also change its location. So I think with these two examples, you can better understand the meaning of center of mass. So in this way, we completed the second point of recall. Which one is the third? Real forces. Yes, students, I know that real forces you have studied in the 11th standard and before that also. Which forces are called as real forces? The forces which arises due to known interaction between the objects, that are called as real forces. And I have given purposely the same example, throwing a ball. Known interaction, I will give the example of real forces. Gravitational force is the real force. The force of attraction between Earth and Sun is the gravitational force. Force of attraction between Earth and Moon is the gravitational force. Second example of real force is the electrostatic force. Force of attraction between electron and proton. third example of real force is the nuclear force, strong nuclear force, weak nuclear force, frictional force also. Number of real forces are there. But what is the criteria? They should arise due to actual interaction between the objects, or simply the force whose source and effect both can be seen. That are real forces. Now we will turn towards fourth point of recall, pseudo force. Yes, this is also we are studying. Pseudo force, non-real force, or fictitious force. This force arises due to acceleration of the frame of reference. And this force has one characteristic. Such force, we don't know about the source of that force, but we can see the effect of that forces. So pseudo forces are the forces arising due to acceleration of the frame of reference, whose only effect can be seen or felt. Source many times unknown. Dear students, I will explain this with one example. One or two examples I will explain. Suppose we all are traveling through a bus, and our bus is along a straight road, and we are all are at each and every seat. We are sitting comfortably. But when our bus is taking turn, for example, towards left, bus is turning towards left. When bus is taking turn towards left, at that time, the passengers inside the bus, we all are inside the bus, experiences push force towards right. When that bus completes the turn and again starts to move along a straight road, that time we all again come to our initial position. The force that we experience while bus is taking the turn, that is the pseudo force. That is the non-real force. And this force arises because acceleration of the frame of reference. मग या फोर्सचा इफेक्ट मात्र आपण बघू शकतो, बट मेनी टाइम्स त्याचा सोर्स मात्र अननोन असतो. आणखी एक एक्झाम्पल मुलांना तुम्हाला मी एक्सप्लेन करेन, आणि ते एक्झाम्पल म्हणजे इलेव्हेटरचं एक्झाम्पल. सपोज वी आर इनसाइड एन इलेव्हेटर, means lift, and if this elevator is moving downward, we all feel lighter than our actual weight. And if this elevator is moving upward, we feel that we are heavier than our actual weight. This feeling of lightweight or heavier weight is due to pseudo force acting on us, because that elevator is in acceleration of frame of reference. And the last point of recall is the rigid body. Dear students, the rigid body, you can call it as a hard body. Then which body is hard body? What is the criteria to call as a hard body? If very large force is applied on a body, and under action of that force, there is no deformation, no change in dimension, no change in shape, size or both of that body takes place, then that body can be called as a rigid body. Can you give me one example of such a rigid body which cannot be deformed under application of force of any large magnitude? कितीही लार्ज मॅग्निट्यूडचा फोर्स जर बॉडीवर तुम्ही अप्लाय केला तर त्या फोर्सच्या ऍक्शनमुळं बॉडीचं डिफॉर्मेशन पॉसिबल नाही पाहिजे. बॉडीची डायमेन्शन चेंज व्हायला नाही पाहिजे. बॉडीचा शेप, साईज किंवा दोन्हीही बदललं नाही पाहिजे. अशा प्रकारची बॉडी डज इट एक्झिस्ट इन नेचर? What will be your answer? Can you think? A body which cannot be deformed under action of force of any large magnitude. Does it exist? The answer is that such a rigid body does not exist in nature. So, idealization of solid body is the rigid body. And in case of rigid body, distance between any two points inside a rigid body remains always constant with time. Does not changes. मग जर आपण रिजिड बॉडी डज नॉट एक्झिस्ट इन नेचर मध्ये म्हणत असेल तर आता यानंतरच्या डिस्कशन मध्ये ज्यावेळी आपण रिजिड बॉडी म्हणू त्यावेळेला ती बॉडी कोणती? तर when we are saying that rigid body, that time we have assumed that applied force has a small magnitude. And by considering the small magnitude of applied force, that body is rigid. But it is not perfectly rigid. So in this way, we shall just try to understand the meaning of physics. What are the different branches of physics? Out of that, mechanics we have selected. And from that mechanics, we have studied the different branches of mechanics. After that, we just overlook the syllabus of our 12th standard. And then we have started the first topic of our 12th standard, which is the rotational dynamics, which has two subtopics, circular motion and rotational motion. And we have started to understand about the circular motion. So with this, we will end today's lecture. Thank you, students.